Bismillahirrahmanirrahim. In previous lecture we have discussed what are elimination reactions and what are the different types of elimination reactions. So today we will discuss about the beta elimination reactions mechanism. So it means the mechanisms are beta elimination reactions. So there are three types of reaction mechanisms for the beta elimination reactions. So three types of reaction mechanisms. The one is bimolecular elimination reaction, or E1 reaction mechanisms. The second one is unimolecular elimination reaction mechanisms. Unimolecular reaction mechanisms are E2 mechanisms. This is E2 and this is E1 reaction mechanism. The third one is E1CB mechanism. E1CB mechanisms mean elimination reaction mechanisms catalyzed by a conjugate base. So this is said to be as E1CB reaction mechanisms. We keep in mind bimolecular elimination reactions represented by E2 in this reaction mechanisms. The reaction taking place in a single step. This is a single step reaction mechanism. Unimolecular reaction is a two-step reaction mechanism, meaning it is taking place in two different steps. And even CB reaction mechanisms is also a two-step reaction mechanism. So this one is also two-step and this one is also two-step reaction mechanism. There is a slight difference between these two E1 and E1CB reaction mechanisms. Now we will discuss all these three types of reaction mechanisms one by one. So the first one is bimolecular elimination reaction, RE2 reaction mechanisms. In E2 reaction mechanism, this is a single step mechanism because this reaction taking place in a single step. It means that the removal of the proton as well as the removal of the leaving group both taking place in a single step to produce a final products. This reaction can be catalyzed. This reaction mechanism can be catalyzed by a strong base. Reaction can be catalyzed by a strong base. It means that we need to have a strong base and we need to have a good leaving groups in order to carry out the beta reactions by E2 mechanisms. So this is a single step mechanism. The removal of a proton by a base and the leaving of the leaving group both occur in a single step, which results the formation of a transition intermediate, and then the transition intermediate is converted into the final product. As you can see here we have these are different kinds of protons. So a base will attack from the back side to remove a proton and the leaving group will leave, which results the formation of the intermediate. So you can see here that this is the intermediate, the base this results the formation of a base will form a bond with proton, and this proton will leave the carbon atom, while on the other hand this leaving group will also leave the molecules. So these dotted lines shows that this bond will be broken down, this bond will be broken down, and a new bond between B and H will be obtained. So in the final step, what had happened, we will be, and here a new bond is also be obtained, so we will get this product. So this is the final product during elimination reaction, beta elimination reactions through E2 reaction mechanisms. You know about the beta elimination reaction. During beta elimination reactions, one of the protons and the leaving group both will leave the molecule, but proton will be replaced from the adjacent carbon atom, while during alpha elimination reactions both the leaving group and the proton will be replaced from the same carbon atom. So this is the difference between beta and alpha elimination reactions, and we have discussed the beta elimination reactions now through E2 reaction mechanism or bimolecular reaction mechanisms. Now we will discuss about the order of the reaction mechanisms. So order of bimolecular reaction mechanisms. So you know that the rate of the reaction, as it is a bimolecular reaction, bimolecular means the rate depend upon both the concentration of the substrate as well as the concentration of the base. Okay, rate is directly proportional to the concentration of the substrate as well as the concentration of the base. So that's why it is said to be as bimolecular reactions. Because it's rate. So you can write this equal and then constant, that is represented by K, and then we have concentration of substrate and concentration of a base. If we check the order, so the E2 reaction mechanisms have second order kinetics. This reaction have second order kinetics because the rate of the reaction depend upon both the concentration of the substrate as well as product. So this is a bimolecular reaction, and in the next video inshallah we will discuss about the E1 reaction mechanisms and E1 CV reaction mechanism also. Thank you so much.